Hi guys, so I mentioned if you asked for help with fractions, packet 2 had a lot of fractions on there, so we're going to take it back to the basics and go through all the different strategies that we've already went through this year that maybe you guys have forgotten or you don't quite remember how they work or you just don't remember at all. So the first one we're going to work on is adding and subtracting fractions. So there are some rules to adding and subtracting fractions. So first, a fraction is a part to a whole. So if I have my fraction here is 3/5, to make it a whole, right now I have 3 parts to 5. So if I have a chocolate bar that has 5 pieces, I have 3 of those pieces. So to make it a whole, I would need 5 out of 5 pieces that would equal 1 whole. But I have 3 parts of a whole. So 3 parts of my 5 to make 1 whole. So because of that, that's what equals a fraction. And when you're adding and subtracting fractions, the first thing is to make sure that your denominators are the same. So your top number here, which is 3, is your numerator. That's your top number. So 3 is our numerator. And our bottom numbers, which is below the fraction bar, are called the denominators. And the denominator in this one is, you should have said 5. The denominator is 5. In 3/5, our numerator is 3 and our denominator is 5. Okay, so when you're adding and subtracting fractions, the first thing you need to make sure is that you have the same number in the denominator, which means your bottom number is the same. So if we're adding a number here, if I have 3/5 plus 1/5, that is, if we look at that, we see both the denominators are 5. So they have like numbers in the denominator, so this is a like fraction. So if you're adding and subtracting like fractions, the denominators do not change. So we know our denominator is 5. And then we add or subtract the top numbers. So it'd be 3 plus 1, which would be 4. So 3/5 plus 1/5 equals 4/5. So and the reason why we do that, our denominators stay the same because they are like fractions, which means they have like or the same denominators. You could do the same problem for subtracting because it's the same rules. So if we have 3/5 minus 1/5, I'm going to put that down here. How do we know that this is a like fraction? You should have said, or you should have thought, that we know it's a like fraction because the denominators are the same, and we know that our denominator for our answer is going to be what? 5, because it's the same. And then what do we do to the top? We treat it as a regular subtraction equation. So 3 minus 1 equals 2. So 3/5 minus 1/5 equals 2/5. Now you notice that the denominators stay the same no matter what. And this is how we add and subtract like fractions. Now I'm going to show you adding and subtracting unlike fractions. I'm going to erase this. So the first one we did was like fractions. If you're taking notes, you should be writing like fractions. And the rules are that the denominators have to be the same. And if the denominators are the same, they are like fractions. The denominator for the answer stays the same. And you add or subtract the numerators, which are the top numbers, like any other equation. So now when we're adding and subtracting unlike fractions, that means maybe we have a fraction like 1/2, which is 1/2. Now, which one is our numerator? Which number is our numerator and which one is our denominator in this fraction? When you're thinking, you should be thinking about that the numerator is the top number. So our numerator for this fraction is 1 and our denominator for this fraction is 2. So if we have 1/2, and we're going to add first, plus 1/3. So in order to add these fractions, we have to look at the rules. So we look, are these like or unlike fractions? And how do we know? So they are actually unlike fractions because the denominators are different. They are not alike. The denominator here in 1/2 is 2, and the denominator in 1/3 is 3. So how do we solve this problem? The first thing you have to do is get a common denominator. And the easiest way to do that is to get these numbers here and multiply them. That'll give you your common denominator. So we have 2 times 3. So we know that this one, we're going to bring these down. So 2 times 3 is what? 6. So that is going to be our new denominator for this problem. 6, and we have a plus sign, and 6. So our new denominators are 6 because 2 times 3 equals 6. So now what you do to the top, you have to do to the bottom. So in order to make this 2 a 6, I had to multiply it times 3. So I have to multiply this numerator by 3. And in order to get the 3 to equal a 6, I multiplied it times 2, which means what do I multiply my 1 here by? You should have said that you multiply it times 2 because that's how you got your 6 here. So now you do 3 times 1 is 3, and 1 times 2 is 2. Now you look at these fractions. Do they have the same denominator? Yes, which means now you can treat it like a regular equation. When you have the same denominator and you're adding and subtracting fractions, what's going to be my denominator for my answer? You should have said 6. And then we treat the numerators like a regular problem. 3 plus 2 is 5. That's our answer. So that one, what we added and subtracted like fractions, and then we just showed adding and subtracting for unlike fractions. We're going to do one more for unlike fractions. Let's do 3 halves plus 4 fifths. So I want you to think about what we're going to do here next, and then I'll tell you. So we have 3 over 2 plus 4 over 5. So we notice that our denominators are different, which means we have unlike fractions. And in order to get a like fraction, we need to have the what? The same denominator. So we know we can find an equal denominator if we multiply the two denominators together. And 2 times 5 equals 10. So we're going to bring these fractions down, and we know the denominator for each of these fractions is 10 because 2 times 5 equals 10. But what we also know is what we do to the top, we do to the bottom. What we do to the bottom, we do to the top. So how did we get 10 here? 2 times what gave us 10? 2 times 5. So which means what we do to the bottom, we have to do to the top. So we also have to multiply this times 5. Then we have here, 5 times what gave us 10? 5 times 2 gave us 10. So what we do to the bottom, we do to the top. So 5 times 2 and 4 times 2. So now we look here. What's 5 times 3? If you don't know your 5s, it's 5, 10, 15. So I know 15 goes here. And 4 times 2, which is 4, repeated addition. How many times? 2 times. So 4 plus 4 is 8. And are we adding or subtracting this equation? We are, in fact, adding. So we're going to add here. So now we have 15 tenths and 8 tenths, and we're adding 15 tenths and 8 tenths. So we have our denominator is what? We know that we have equal denominators here, so the denominator for adding and subtracting is going to be the same as here, and it's going to be 10. And then we have 15 plus 8. So you have 15, 16, 17, 18, 19, 20, 21, 22, 23. So we have 23 tenths. Now, some of us may think that 23 tenths is not a correct answer, but it in fact is. There is a type of name for this fraction, and we should know it, but maybe we forgot. So it is actually called an improper fraction. And I want you to think, what makes it an improper fraction? So what makes it an improper fraction is that the numerator is bigger than the denominator. So that means it's improper, which means somewhere in here is a whole number, which means we don't know how many wholes we have because we haven't done it, but there are whole numbers in this answer. And then we can create what is called a mixed number that has a whole number and a fraction in the whole answer. I'm not going to ask you to do that today. If you need help with that, please let me know. Please leave a comment down below if you need help about transferring mixed numbers, converting mixed numbers into improper fractions, or converting improper fractions into mixed numbers. I can also do a video on that if that's what the packet is asking you to do. I don't know if it's asking you to do that, but if it's just asking you to solve an equation and give an answer, this answer is perfectly acceptable. If I were to ask you to solve this problem and you were to give me this answer and show me your work, you would get an A, because that's what I asked you to do. Now, if I would tell you, please answer this in the simplest form, then that means you'd have to simplify, or you'd have to give me a mixed number. If I said, please answer this without an improper fraction, then you'd have to give me a mixed number, which is a whole number and a fraction. But for this purpose, for just solving this problem, I just asked you to solve this and showed me the correct way and using a correct strategy. This is correct. And our answer that we got was 23 tenths. So that's all I have for you today for adding and subtracting fractions. My next video will be on multiplying fractions, or we might do multiplying and dividing fractions. So I hope this helped you. If it didn't help you, or if you need more help, or if you're more confused, please let me know. Maybe I can do another video, or maybe I could Zoom chat with you to kind of explain it as we go, or to look at the exact problems that you're looking at. If you already know what you're doing about adding and subtracting and you just watched this video, if this is what you remember, then give me a thumbs up. And if not, leave me a comment. Let me know if there's something I did wrong or something you don't like, something that you need clarification on. So I just want to be sure the first half of the video was adding and subtracting like fractions, and that means that they have the same denominator. And then when you're adding and subtracting unlike fractions, which is what we just did, you have to figure out the common denominator, and then what you do to the bottom, you do to the top, and you bring it down and solve your problem. So I hope this was very helpful to you. Please look for my next videos on fractions. The next one should be having to do with multiplication and dividing. I hope you have a great day, and I hope this made your lives a little bit easier while doing distance learning from home. Bye.